Hi, I'm Penny and I'm going to give you a quick talk on open challenges in genetic improvement for emergent software systems. This paper was by myself and Barry Porter. Let's start with emergent systems. Emergent systems are made up of lots of small blocks of code, such that when the environment in which they're being used changes, they can be swapped out at runtime to optimize to their new environment. Where does genetic improvement come in? Genetic improvement provides us with a population of variants of each of these code blocks that we can optimize at runtime and insert an optimized block into our emergent system to respond to environmental change. But there are distinctive limits on genetic improvement within this context. First, because the code blocks are small, less than 200 lines often, there's very limited genetic material. Two, because we're in a rapidly changing environment, there's very little training data with which to perform this optimization. And three, because we need to update in response to that changing environment, we have very few generations in which to do that, less than 1,000, for instance. This poses four major challenges for GI. One, how do we search the space given that genetic material is so limited? Two, how do we make sure that we are producing generalized results rather than over-specific results given how little training data we have? Three, if we have a large change in our environment, how do we navigate between those distant optima, given we have limited genetic material, a single start point, and very few generations in which to do it? And four, how do we improve our use of human guidance to try and meet these challenges? So far, we've got work in progress on both searching the space and generalization, and we're hoping to address the second two challenges in future work. Thanks for listening.
It seems it's very new, but very interesting. Like, any suggestions?
They don't really exist yet, and part of the problem is that I'm not sure there would be a good benchmark data set, because part of the point here is that these systems adapt very quickly to their environment and very specifically to their environment over time. So probably the difficulty of getting a large enough data set to benchmark is not as useful as building these systems with a purpose in mind, I think.
Yeah, so I think we have the same question from both Steph and Wes. So they are asking, can you give a few examples of the emergent software system you're interested in?
So there's a few different ones that I think occur immediately. So there's things like server management systems, where you've got varying input over time that you're wanting to redirect in varying different directions, and all those, the traffic and load. A lot of these good emergent systems are dealing with sort of traffic and sort of network systems, because your traffic and load can vary over time in the short term and in the long term. So you want to be able to adapt short term to a sudden spike. Say a new news story happens and suddenly everyone's looking up the same web page. A system that can adapt to that is quite useful. But also more broadly, having the idea of these emergent systems is you can teach them and set them up to adapt however you need them to. So actually having a system that prioritizes processing most when things are busy, but prioritizes energy savings maybe when it's quieter, it is the kind of idea behind these emergent software systems as they swap and change their different blocks over time.
Gotcha. So another question is from Bill Landon. Could genetic material from other, like a similar problem to be used?
Absolutely, and this is something we're quite interested in, seeing how we can incorporate more genetic material into our system with curation systems that use things like phylogenetics to actually look at how did this mutation over time affect our system and allow it to continue. Was this a good piece of code to be adding or a bad piece of code? And by looking at over time how these mutations affect things, more of a phylogenetics approach from biology, we can hopefully start using more horizontal gene transfer, more code from other places in these systems.
So Mara mentioned there are types of a self-adapt system for sure. I'm also thinking about like a cyber physical systems where it can be a lot of dynamic changes over time. So, okay. Yeah.
So this is definitely part of the same set. It's a self-adaptive system and what we're talking about here is we've got emergent systems use these modular bits of code, and they want lots of options. And by adding genetic improvement on, we can actually be optimizing their options at that time, in real time.
Yeah. So there's some suggestion question from Wes. You have to do the optimization quickly, but perhaps you can pre-compute information beforehand. Could you pre-measure the relative effects of the different code pieces to guide the search? What do you think?
So there's quite a bit of work in emergent software systems of having just a pre-computed set of variants and when they're good and useful. And that's very good for when you know what the environment's going to be at deployment. When you know that this is the limit of your space, these are the different things that can happen in it. But the reality is that we've got a lot of very large, very complex systems in the world now that are doing a lot of very important jobs, and anticipating all the circumstances for their usage isn't possible. So we do need something. So while we can pre-compute for the known events and environments, we also need the ability to compute in response to the unknowns.
Gotcha. So there's some more discussion here from Wes. So some of the older approaches, like a clear view, would change the code to use runtime monitoring. Could you use a similar approach here? For example, generating, if this value, let's say, gets too high, use a code chunk X instead of code chunk Y.
We've already got people working on that kind of adaptation for emergent software systems, and it's definitely a good adaptation. As I say, for when you have those sorts of switches that you can identify beforehand, it's absolutely brilliant. And one of the advantages of GI actually that we're thinking about going forward is taking a more biological approach, because niche finding in biology isn't done by a singular population. It's done by lots of different populations in that environment, and one of them will find that niche. So one of the thoughts here is, instead of running our GI over just one starting point of our code, what if we use multiple starting points and actually allow evolution to work out which is the right one to adapt quickly?
Gotcha. So there's one question from me, because I know in your paper you mentioned that for large leaps to allow us to adapt to some of the big changes, we may need human guidance. I wonder what kind of information shall we provide to humans for them to make manual guidance? What kind of information in your mind?
So this could be anything from telling it needs to increase how much extra code it's inserting into the system, or how much it's borrowing from other code bases, or actually just adding in, making available to the system new blocks of code that has different logic in it, providing the genetic material you think it might need to make those leaps.
Oh, I see. So you're basically saying human users, they can provide sort of like a library or corpus?
Yes, yeah, and we can introduce, and if we can see that the system isn't getting where we want it to go, we can say, I think this logic might be helpful to you, here, add this to the corpus. Or we can also we can also look at how we're testing our systems. So if it doesn't seem to be dealing with a change, that might be because something's happened that we're not actually testing for, or not encouraging in our fitness function, as it were. And so making those modifications is definitely where human guidance could come in.
Gotcha. Okay, thank you. Perfectly in time.
Brilliant.
Yeah. All right. Yeah. So Penny, can you see the discussion room option here?
Probably.
Bottom right. Can you see that? Go to the discussion room.
It hasn't popped up quite yet.
Oh, if not, you can. If you haven't seen that, you can go to the conference part and go to your paper. There's a discussion room option there. So You probably want to go there and check if anyone waiting for you there. Yeah.
Excellent.
Okay. So I'll just leave the room. Go to my
Yeah, you go ahead.
Bye. Thank you. It's a great Q&A.
Here on behalf of the